Hello everyone, and welcome to today's Real Data Science Meetup, where we're going to be discussing the new kid on the block, the linguistically challenging LLMops, and how you can use it to streamline your large language model development environment and processes. Joining me today, we've got Caitlin Brabbits, a data scientist here at PA Consulting, who's going to talk to us through some work she's done in developing a sort of starter pack to really help accelerate the incorporation of LLMops into your data science and LLM workflows. Before we get to that, as usual, we're going to lead off with a bit of a chat between Caitlin and myself, get to better know you, your career, and why we're talking about LLMops at all today. But before we get to that, in case this is the first time joining for any of you, I'll give a quick intro on what this series is. So, the Real Data Science Meetups is a series of global live streams and in-person events running every 6 weeks to 8 weeks out of London, Utrecht, Denver, and Copenhagen. Data scientists from our team here at PA Consulting sort of go deep, presenting a blend of theory, code walkthrough, and all that sort of historical context to cover a technical area of interest across sort of data science and machine learning. The hope with these sessions is not only are they fun and a chance to learn something new, and I learn something new every time basically, but that they start to open up discussion and create a space for the data science community to sort of grow around them. So if you want to follow the series, see where and when the upcoming sessions are going to be held, or provide any feedback or suggestions of what you'd like to see in future editions, follow our Meetup network or subscribe to our YouTube channel, Real Data Science, where hopefully you're watching this today. So, with the intro out of the way, I'm excited to open up the session properly. Good to have you here, Caitlin.
Thank you.
Normally you'll spend a lot of time on the other side of the desk, and the other side of the camera, making these sessions run behind the scenes, so it's a real treat to have you over here for once. To kick things off, because it's always the question I like to ask first, I think it's really telling and interesting and speaks to the different journeys people have getting to a place sort of working in data science. I'd love for you to tell us a bit about how did your career lead to you working here at PA in data science?
Yeah, so it's been quite a crazy journey. I absolutely did not do anything related to data science or anything technical in my university or even in my first couple of roles outside of university. I didn't even know it was possible to even go into it or if I even knew I liked it. But when I was in more of a marketing role, I was trying to give more of an edge onto like what I was doing on a day-to-day and kind of more of an edge in my career perspective of where can I give myself some growth. And so I found out that I really liked more of the analytics side of marketing. I even knew I liked it in one of my marketing classes. We had a marketing analytics class. And so there was, I looked online trying to find more of like the tech with marketing because tech is the future, etc. And I found out I could actually kind of teach myself Python and kind of implement Python more of the analytics side into my marketing role. But luckily, about 2 years from around this time, PA did a career changer scheme, a Women in Tech career changer scheme, and that was at the same time I was learning Python. So I took a leap, and yeah, I got here. I've been here for almost 2 years now, and yeah, it's completely changed my life, to be honest.
It's such a cool story, and I remember back when you and others on the scheme joined, and yeah, you've done a lot since then. You've sort of taken those skills, you sort of self-started and grown them a lot further. But I love the sort of story of the marketing background and thinking about what interests me here, because that idea of marketing analytics is such a clear focused area of how can you use data to sort of make a tangible change and improvement to a sort of business outcome, which is a lot of what we do here as data scientists, data engineers, sort of data technicians in a consultancy. It's about doing something really smart and innovative with data, but to an end. And that sort of follows through really, really cleanly. Cool. So the other one, today we are talking not about DevOps, not about MLOps, but LLMops. And also it's sort of a personal project you've been working on and developing to create a starter pack to help developers actually put LLMops into practice. And you're going to show us some of that later. What was it that drove you to sort of, I guess in your own time, pursue this and decide I want to start building this out and exploring this very new area?
Yeah, so it was actually my first project at PA, because that was the first time I experienced being in more, instead of my own little pet projects on my own, in my own environment of creating little projects, whatever it may be. This was the first time working on a technical project in a team, and realizing the complexity it can mount on with dependencies, different operating systems, etc., where it felt like it was so much of doing that work than actually doing more of the fun bits that you wanted to do, especially if you joined a project which was already ongoing and not starting from scratch. So to me, I was like, where is there, I know there's out there, so like the DevOps, etc. And now that we have, this little trendy word, LLM, generative AI, I was like, why don't I kind of merge that together, since it's kind of a new project type, new ideas. Even though LLM's been here a while, it's just buzzwords. So I thought, how about I create just an initial little starter pack to get going. It doesn't have everything related to LLM ops pieces, but it is somewhere you can scale and get going. So that's kind of what drove me.
I really like it because one thing I think we find in the world of data science is that as a data scientist, you might be doing things on your own, but you might also be working in small sort of machine learning or data science focused teams, rather than the sort of larger scale software focused teams that might have specialists there to sort of sort out that DevOps process and actually ensure that integration is automated and secure and has all the right testing in. As a data scientist, that isn't normally your expertise. That's not why you've been brought in, and you're frequently not working in teams where you actually have that person sort of doing it all. And so that ability to be a self-starter and have the tools to hand to sort of help yourself put it in place from that position, I think is something that's going to be more and more in demand. It's something I'm always thinking about. I do quite a lot of architecture work alongside data science, and I think we should have that aspiration as data scientists to be thinking about how we productionize it and how we don't just confine ourselves to our own machine. So I really love it. And I think in the world of large language models, that ability to start developing with ML, the barrier to entry is lower, which is all the more reason we should be creating sort of starter packs and toolkits to help people ensure that what they're building is robust. So I've loved sort of following this, and I've loved sort of seeing the materials you're about to talk through. Which is a perfect segue, I suppose. So Caitlin, I'm gonna hand over to you, and you're gonna give us a bit of a run through, I guess, your journey in LLMops, what you've built, and then later on we're gonna hand over to a sort of video talking through a live demo of some of it in practice. So Caitlin, over to you.
Perfect. Thank you, Max. I will start. So just to kind of do an overview, we already if you're here listening, we already have an idea of what MLOps is. We understand that it's a practice of merging machine learning and DevOps to streamline the end-to-end machine learning lifecycle. We also know it enhances collaboration and automation. It makes have a more reliable ML model deployment, helping with faster go-to-market and also saving with costs. It empowers agility and strategic decision-making, as well as it's adaptable and customizable to different needs. And as you can see in the image, it's a continuous process of these modules that you have for machine learning, and it also helps actually with more of the outside, with the front end, whatever kind of outside that machine learning piece. It helps integrate smoothly with different softwares, etc. So we do understand that. So how is LLMops different from MLOps? And basically what LLMops is, it's just a subset of MLOps, so a lot of it overlaps. There's a lot of consistencies with more of the generalization type pieces. But there are some pieces that are slightly different and more of a different scale for large language models. So one of them is language-specific challenges. LLMs handle language-related tasks and they need language-specific data preprocessing and augmentation, which can be slightly different compared to some of the traditional ML models. Prompt engineering, it's crafting effective prompts. It's pivotal for shaping large language model behavior, involving iterative experimentation to optimize those desired outputs. Transfer learning dominance, LLM development revolves around pre-training and fine-tuning, relying heavily on transfer learning from large pre-trained models. Computational demands, so LLMs specialize infrastructure and substantial computational resources due to their size and complexity. And lastly, it's the human feedback loop. Continuous large language models performance improvement hinges on incorporating human feedback loop through model refinement. And so that's just a little bit about the differentiation between the two, even though it's overall a subset of MLOps in general. So, some of the challenges that LLMs face. First one, we kind of already talked about computational resources. Training those LLMs demand a substantial computational power and memory, and it can end up being very costly and time-consuming. Data requirements. Massive data sets are essential for high-quality results, and data acquisition, cleaning, annotations are challenging and also costly. Ethical concerns. So concerns about misuse, including generating fake or biased content as large language models become more powerful. Actually, Clara Bernstein, she's actually done a bias on NLP on one of our Real Data Science, so definitely go check that out. Little shout out. Model interpretability, Understanding large language model decision making is difficult, impacting transparency and explanation of their behavior. Transfer learning and fine-tuning. So fine-tuning pre-trained large language models require careful organization to avoid, optimization to avoid forgetting and ensure generalization. And lastly, deployment scaling. So efficient scaling for handling high volumes of requests in production without you need that to make sure there's no compromising performance.
I love this slide. It's fascinating, isn't it? Like, it feels like just yesterday, say at the start of the year and end of last year, when ChatGPT was first coming out, and there was so much excitement, but also so much unknown sort of about what does it mean for these large language models to be here for us building with them, and to see over such a short period, it's now so much more known, so much more mapped out. Well, these are the things we really need to hit, and you maybe could have guessed them before, but I really love this slide for giving that picture of, well, these are the things we struggle with, and that they can be guidelines for, well, how do I want to fix them? How do I build something that makes this easier for me?
Yeah, and I also find it fascinating that, like, at first it's just this big boom, this is excitement of like this new product idea, and then all of a sudden, slowly but surely, people are like, oh, well, actually, if I try to make a large language model, that's going to cost me. Worrying about biases, worrying about making sure the optimization of the fine-tuning. So it's all these little pieces that once you get to understand more of that back end, you're like, oh, this is actually quite a bit of work. And that's what definitely, when I built this, I was like, ooh, it's extra stuff that I didn't think about before. So, yeah.
Nothing will ever be quite as easy as we'd like it to be.
True. So now that we've talked about the challenges, I kind of want to talk about now the benefits of having LLMops. Again, some of this do overlap with the traditional MLOps, but I just kind of wanted to, some of these pinpoint targeting more the LLM specific needs. So first is around deployment. So we want to ensure seamless deployment and scaling of large language models like ChatGPT. We also want to have, we want to be able to manage the resources efficiently through auto-scaling and load balancing. And we also want to set up redundancy and failover mechanisms for uninterrupted services. We also want to implement an iterative development cycle for ongoing model refinement, track performance metrics for quick optimization and issue detection, as well as implement automated validation for bias, security, and model drift detections. Under governance and security, ensure data protection and regulatory compliance, monitor and adjust resources to minimize the operational costs, as well as it will maintain model data and code versioning for reproducibility and auditing. And lastly, collaboration, my favorite. Streamline teamwork among data scientists, engineers, and domain experts. So it's not just all focused about the data science contribution. It's thinking about the whole picture of everyone else that's doing their different parts within the whole application, for instance, because it tends to be a lot more ChatGPT-like products. So,
and I think especially when you're thinking of this use case of, I'm bringing LLMops because I want what I'm building to be production ready, to be robust, to be automated. That is exactly the sort of time when you're likely not a data scientist plugging away on a laptop anymore. You've got to be thinking about, well, where is this data going to be sitting and going to be optimized and going to be cost effective, and how are we going to be making sure it's actually going to be used in a way that's effective, so I think building this sort of machinery and mechanism needs to be incorporating, well, there's going to be other people involved as well. So I think that collaboration, you say it's your favorite, but it is one that probably flies under the radar. It's easy to be excited by sort of CI and deployment, but there's a big picture here.
Yeah, definitely. So next, I kind of want to talk about some common components within a large language model project. So first is more of the data preparation. This is kind of the ingestion and pre-processing. So web scraping, open source repositories, and expert collaboration. And around the pre-processing is cleaning and tokenization and normalization. Then we have data labeling. So human exports are crowdsourcing with techniques like active learning. Then databases. The most common for large language models do tend to be vector databases, but doesn't mean it always has to be a vector database. But that tends to be the more efficient, more accurate type of database for this type of project. Model adaptability, transfer learning and multitask learning improve the adaptability and performance of the project. Fine-tuning, it adapts pre-trained large language models for specific tasks and focus on that hyperparameter selection. We have hyperparameter optimization, so controlling the model behavior, requiring optimal configurations. So techniques like grid search and Bayesian optimization enhance those performances. Prompt engineering, it's that crafting the appropriate prompts, guiding the LLM to produce desired outputs, enhancing their controllability, adaptability, and efficiency, and delivering those meaningful responses. And then lastly, the front-end integration. It's designing that user interface and interaction point for the users to effectively utilize the LLM, ensuring user-friendliness, real-time feedback, data privacy, and security. So we're kind of getting in a little bit more of the fun stuff. So, so we have here more of this is the architecture I've built for the starter pack. So as you can see, we have two different Dockers, one for that web application front end, and then we have one more for the back end, which has all of the things like the database, the large language model. We even have LangChain in there, our data. So it's very small, so it's okay right now. Definitely looking into the future on maybe branching those out, but for the time being. And then we're using, for the backend server, Fast API, and for the, I lost the word, but it's the library, package, the package dependency manager. So. So that's just kind of the high-level architecture. You can see that it will talk to each other, sending the query to the large language model, and then sending back the response to the front end or the client. So going over some of the tool stacks. So there's two big ones in this starter pack. The first one is around the operating system protection, which is using Docker. So Docker, it's a standardized and efficient way to package, deploy, and manage any kind of project, but in this specific case, a large language model and the associated components. So some of the key points around this is Docker is a way to simplify your deployments through containers. It can easily deploy those models and other components across various environments and platforms, so you don't have to worry about someone else having a different type of computer. They would all work under the same. Isolation of environments, so you isolate the language model environments, dependencies, and configurations compared to the front-end dependencies and environments, etc. You can prevent conflicts between different components, for example, the back-end and the front-end. Enhanced portability. Docker containers are lightweight and can be easily moved between development, testing, and production environments. And it minimizes that it works on my machine type of issue. Then we have scalability and resource efficiency. So Docker containers are highly scalable and they utilize system resources efficiently. And they also enable auto-scaling to meet varying workloads and optimize resource usage. And lastly, streamlined collaboration. Woo! Ensure that your entire team works with identical environments and you're able to streamline collaboration between data scientists, engineers, and developers. So I kind of like this image. It kind of gives you a high-level architecture of how Docker works. So I'm going to kind of go a little bit backwards in it, but you have the images, so which I can show. It'll be a different slide. And then you also have the containers, and those are linked together because you have to use the image to create and build that container. You can, as a client, you can go through the front end or through an API to reach the Docker. And also you can actually, if you've created your own kind of Docker image, you can publish it into the registry and other people can use it. So it's quite cool. It's quite cool environment to be in sometimes. So
yeah, I think again, it's one where the Docker's used more in that world of software eng often than just straight data science, but the idea of virtualization of sort of OS and allowing that consistency across teams, deployment across environments, all sorts of things like that. It's a tool that is just wide-ranging in being powerful. And I think one of the questions that often ends up coming to my mind as a sort of data scientist on work is, what's the point in time at which actually I can go from, I should be going from, oh, I'm testing an idea, I'm trying to prove a concept, through to, okay, I should really start thinking about how I start to build the architecture around this that allows it to be scalable. And when does Docker come into it in my mind? And often it comes to sort of, well, when am I trying to attach it to a front end, as you sort of suggested, or when am I trying to get it off my laptop's compute and into the cloud? But it's something I think more and more data scientists are realizing this is a really key part of what we do if we want to turn it into anything sort of significant. Yeah, definitely. So some of the Docker components. So I've mentioned a little bit in the other slide, but firstly, kind of the basics. So if you're going to use Docker, these are going to be your absolute go-to. Otherwise, you're not going to have a Docker. So first is a Docker file, which is pretty much a text file, but it contains a set of instructions for building that Docker image. So it's kind of like a step-by-step. Then you have the Docker image, which is a read-only template that contains everything that you need to run a container, including the code, runtime, system tools, libraries, and even settings. And then you have the Docker container. And this is a lightweight, runnable instance of the Docker image. They provide process and file system isolation while sharing the host's operating system kernel. Next, I've put in here Docker volume. So this is around managing and
manage and persist the data for your Docker containers. So in situations where your Docker container is running and you've created data inside of a database, for instance, but it crashes or it shuts down for some reason, that data's gone. Is bye-bye. So with using Docker volumes, you're able to store and share that data between the container and the host by mounting or binding. And then it's an independent of the container lifecycle, offering that data persistence. Mostly this type of using Docker volume is used for configuration files, databases, and data survival through updates or restarts or crashes. Then we have Docker Compose. This is, it defines and runs the multi-container of the Docker application. So for instance, my starter pack has 2 different Dockers, so I use Docker Compose to be able to use both of them to run. Also, it describes the services, networks, and volumes in a simple YAML file. It simplifies the management of the complex container setup. So instead of having to build, run one container, build, run another container, and then how do you get it to talk to each other, the Docker Compose actually simplifies all of that. And also it starts, stops, and scales services with just a single command. So that's quite nice. Then lastly, Docker Network. So this enables communication between the Docker containers. So that's what I'm talking about when it needs to speak to each other. And you can define that again in the Compose YAML file. It allows containers to connect to each other and other external networks. So not just the containers, but the outside world when needed. And it provides more of a network isolation by defining it, as well as more security. And it offers various network drivers and configurations for different use cases. Next, I'm going to go into, honestly, my favorite thing ever. I think everyone in the office understands. So this is more of a library dependency protection. So no more pip, poetry only. So what is poetry? Well, it's a powerful Python dependency management tool that simplifies package management, enhances reproducibility, and streamlines project publishing. So it makes dependency management easy. So it simplifies your Python package with a single, easy-to-understand TOML file. It also streamlines your project configuration for efficient and consistent package management. For dependency resolution and reproducibility, it ensures reliable, conflict-free dependency management through a robust resolver and a poetry.lock file. It also isolates the virtual environments to avoid system-wide installation and conflicts. It deals with the Python version compatibility, so it manages it for you. So when you initiate your poetry project, you can actually define right there what kind of Python version you want, instead of depending on your operating system or etc. It kind of defines it and you don't have to worry about it. And when you install new dependencies, it's related to that version, so you know that it will work. It also allows you to specify supported Python versions as well. And lastly, documentation and sharing. It automatically generates comprehensive project documentation and simplifies packaging and publishing to PyPy if you want to do that, as well as it makes it easier to share your code with the community. It's a simple wheel file when you publish out, so it's quite nice. So some core functionalities with Poetry. So project configuration. It uses a central configuration file. It's called a pyproject.toml file to define any project dependencies, metadata, and build settings. It pretty much simplifies your project management and ensures consistency. Dependency management, so I've added some little commands. It's quite simple, so poetry add pandas or poetry remove pandas, and it completely, I'll show you in the demo as well, but it pretty much streamlines that dependency management by allowing you to specify your project dependencies, including package versions and constraints. It also handles installation and resolution of dependencies effortlessly. For packaging and distribution, it includes a built-in tools for packaging your Python projects into distributable formats like wheels and source distributions. You can easily publish your project to PyPy or other repositories. And lastly, virtual environment integration. So Poetry simplifies the creation and management of virtual environments. It ensures project dependencies are isolated, compatible, and enhances the project stability and reproducibility.
I remember when you first showed me some of the stuff you've done with Poetry. I saw the summary you gave here, but with examples that I guess we'll see later on.
Yeah.
But I was working on a project with a piece of work with a really smart team of machine learning engineers. But between us, we just couldn't find a way of managing these sorts of dependencies that felt easy.
Yeah.
And I don't want to oversimplify it. There's a bit of setup involved, but some of these things around virtual environments, around the documentation part, around just how simple some of the commands are, it made me sort of think, yes, I need to bring this to the team, and we need to sort of start using it. It really is just cool. It's worth looking out for these new tools coming out, because there's always sort of, it's sometimes the little things, but there's continuous sort of evolution in the space, and why use something that's sort of out of date or shoot yourself in the foot when there's something cool and new. So I love the Poetry stuff as well.
No more having to remember what's in the requirements txt file.
Absolutely.
So next, I just kind of want to talk about, so I do have the starter pack, but of course I kind of want to keep building towards it. So some of the things that I'm looking out for are what kind of scalable CI/CD, more generalized, that it doesn't have to be maybe GitHub workflows or something along those lines. Something I can maybe do, a Python script or something that can kind of generalize that. I don't have any fine tuning in it right now, or logging, testing, and analytics. I do have a prompt, but I don't have any prompt engineering related to it. So these are the kind of things I'm looking out for to kind of build towards that. But yeah.
Cool, and so that's the end of, I guess, the initial preamble. And in a second, we'll switch over to a pre-recorded demo.
Yep.
For the people here in person today, we'll do a bit of a hands-on in-person demo. So that's encouragement so if you ever want to come down and come to these sessions in person, do, please. It's really fun. We get together, have a chat, and explore the topics, and there's a lot of discussion. So check the Meetup network for sort of links and forewarning around that. Before we hand over to your lovely pre-recorded demo, where we actually get to look at the starter pack in actuality, I do want to make everyone aware about an exciting event coming up. So if you want even more from the Real Data Science meetups, we have you covered. So it's 6th of December. Additional details are going to come out soon, but we're having a Real Data Science meetup conference. So there's going to be speakers. It's going to be sort of held across London, Utrecht, and Denver, I believe. And details are going to be coming up onto our Meetup network soon. Links should be in the YouTube description. So we're really excited. It's going to be fun. It'd be great to meet any of you, or any and all of you who want to come along. And if you have any suggestions about things you'd really like to hear about in that conference or in upcoming sessions, do add a YouTube comment or reach out via the Meetup network. And with that, we would like to say thank you. I'd like to say thank you, Caitlin.
Also thank you.
And we will move over to the video. So speak soon. Bye.
Starter pack, which I'm going to go over specifically the kind of the Docker and Poetry structure within it, not really in depth the code itself. So I kind of wanted to start off with actually just kind of running it, so you can kind of see what the output looks like. Oops, let's Docker compose up. So by doing this, this is allowing me to use this compose YAML, which I'll go through, and it will pull up both of the Docker containers. And we'll just give it a second to run. Okay, and now we have our database generated. These are just little print statements. But let's pull up the front end. So this is a simple front end, has the AI asking it a question. So we'll just type in a copied and pasted question. So just out of simplicity. So it's running. Loading, and then we get an answer. So quite cool. So everything works. So now I can kind of actually go into more of the code. So in this starter pack, we have two Docker files. So it's like I was showing before. It has one in the LLM, so a Docker file, and then one inside the front end right here. I've made it quite simple. So as you can see from this one, this is the LLM one. It's very simple. We're using a Python image source. So that's usually what the from means. And then we install poetry, which run kind of defines doing like more of like what you would do in the command line. So when you would pip install or poetry add, etc. The working directory I've defined inside the Docker container to be LLM. So when you go inside that container, all of our sources here would actually be called LLM inside, otherwise it wouldn't be there. And then we copy this. This is just copying files into that directory that we've defined in the container. So in this case, why wouldn't I just copy it all is because we want to install the dependencies first. So by doing this, it actually makes the build time slightly quicker. And then so we copy that, then we do again poetry install. And what this is doing, which I can go a little in depth later when I go over poetry, is around how this installs all the dependencies that are dependent on that are inside this pyproject.toml file. And then after that is done, then it copies copies everything else that's in the directory of the Docker file, which is everything underneath LLM, and copies it into that working directory of the LLM. So just by using the dots, that's what it's defining. Expose usually talks about ports, but I've commented it out because I have it in my command. And then in our command line, we have each part of what you would do. For instance, like pip install poetry, you actually separate it with quotes, with a comma for everything. With poetry run, when you see this, you can usually use this with running with your Python scripts, but also it starts up your virtual environment. So I wanted to make sure the virtual environment is working so it can gather all the dependencies to work. Then Uvicorn, main, app, hosts, etc. All of this is related to the Fast API, so the backend, and how it gets the server to run. So that's very simple. I've made it simple due to the fact that I want it to be versatile for anyone to use. So if they need to have, for instance, something along the lines of adding things, they can. Then we have the front end. So this is all, it's using TypeScript, React, and Next.js. So we're using a Node source image. Then we've created, again, the working directory of app. We've copied the package.json. This is around the dependencies for the front end. Then we install those dependencies. Then we copy the rest. Similar, same structure. Then I've exposed the 3000. Again, that's related to which port. We have to have two different ports, otherwise we can't have two of the same sources going into the same port. So you have to define two different ports. And then the command is npm run dev. So that is the front end. And now I can kind of show you the compose YAML file, which this is just pretty much used again for building multi-containers instead of having to separately build each of your images separately, then run them. It's kind of a nice, concise way of just a simple command line, and it runs both of your container. It builds your images and runs your containers if necessary, or it uses the latest image. So version 3, this is quite common. It's just the type of version of your compose YAML file. And then services, we have the LLM is defining the service. So service 1, for instance, and then we're building with the context of where is this located, which is in our LLM file, using Docker file. And then we're using if there is an image, we'll use the latest one, or it'll build it. Then we've defined the ports, so mapping the ports to and inside the Docker, and then having a network so it can share in between whichever ones you need. So if there was more than one service and you had two different networks and you wanted to make sure only, for instance, if we had a database separate and it needs to be on a separate network, and you can have, for instance, the back end have two networks that can connect to, so you can define that below down here. Or so then, and then the chatbot would only have one, and it would connect to only this. So there's isolation on networks as well. So again, similar, same structure on this as well. So quite simple, very versatile. If there's things that you need to add or anything, you can build off of this because we know this works itself. So that's just a little bit about Docker in this way. There's also fun ways that you can do. Now I kind of wanted to show you some simple Docker commands that wouldn't be in relation to, for instance, the Docker compose. So if you wanted to build an image, you just do this down here in the terminal. I might make this a bit bigger just so we can see. So Docker build, this is building the image. So first of all, you need to be in the right directory. So I'm not in a directory that would have a Docker file, so this would fail because it would be like can't find a Docker file to build. Again, we need the Docker file to build the image, and the image helps is kind of a very lightweight to be able to make the container itself. So, and it has all the components inside, which I've mentioned in the first part of this. So Docker build, and then T, and these are just small little parameter, honestly. Docker build T, then you want to put the name of your image. So I'm just going to say LLM2 just because there's already an image I've built already. Then you have to put the path. So if you wanted to, I could have done MLOps demo and then did the path, but I just like to be secure and just be inside the same directory as the Docker file. So I'm just going to put a doc saying and right in this directory. Oh, I didn't even cd, sorry. So cd LLM, then Docker build image T, and then LLM2, and then right into the dot. Oh, silly me, I did not need image, so Docker build T, oops, T, and then LLM2 in the same directory. So this is just building the image. It's taking all the step-by-steps, as you can see. We're pip installing. It's caching because I've actually done this before, so Docker finds ways to make things more quick and efficient, especially if you haven't changed anything. So now it's copy. Perfect. Now we know that it's run or it's built. We can also look here. So Docker image ls, and we can see LLM2 here. Now we could do to build your container. It's actually Docker run this is making it interactive. And then I always like to put a name because it will do an automatic name. So I like to put name, and then LLM container 2 just in case, and then you have to put the Docker image LLM2. So it's just loading here. As you can see, okay, cool. So it's running and you can actually see, I'm just pulling up a new one just so you can see. You can do Docker container ls, and this is where you can see all of the ones running, and then you can also do Docker container ls.a to see any of the end ones that are not running, for instance, but still there. So one thing to remember is that with Docker Compose, it actually removes the container, but won't remove the image. If you wanted to, that's the big thing with Docker is if you make changes to any of your files, you have to rebuild the image. That was something I had to get my head wrapped around when you make a change and then you try to do Docker, try to run your container again, it won't work because you have to update that file or update the image. So this is perfect. Then if you wanted to stop the container, so it's Docker stop, and then you put in the container name. So this stops it from running. And then as you can see, we can do Docker container ls. We'll do A. And then we see the status that LLM2 has exited. And then if you see this, this means it's still running. And it gives like the ports and different names, etc. And then if you wanted to, I'll go back to this, and then you can Docker image remove LLM2. Oh, I didn't. Interesting. Container ls. Oh, you have to, sorry, that's what it is. So you need to remove the container first. So Docker remove, and then LLM, what was the name again? Let's do Docker container ls.a, and then that is removed. Oh, no, it's not. So Docker remove this. This removes the container. Then you will do Docker image remove LLM2. And then you can actually see both ls.a. As you can see, it's not there anymore. And then if you go into Docker image ls.a, you don't see any image, so we removed that image as well. So that's a little bit of some of the commands within. There's definitely a lot more out there. I definitely recommend if there's more in-depth, more pieces that would go related to however you want to build off of the project. That would be going to the documentation, finding the different pieces. There's extra like entry point inside the Docker file, and you can define so much more arguments, for instance, environment variables. But I didn't need to really do this for this project, so I didn't want to add things that would be unnecessary in the build time. So Next, we'll go into poetry. So let's just delete all of this to kind of leave some space. So with poetry, I mentioned a tomo file. So the front end won't have it, so I'll kind of minimize that. But in your project, when using poetry, you absolutely need a tomo file. Usually when you create your poetry, like initializing it, it will automatically create a tomo file for you. So within this tomo file, it's very similar to almost like a requirements.txt, but it has a little bit more to it. So we have our name. This is mandatory, so I'll show you also like a step-by-step on how it builds itself. And then we have a description. I filled it blank just because I know this is kind of more of a use by use cases. Then you put the author and then a README file. It is quite picky with README files, so sometimes you might end up, there's people I've seen online that will, because maybe you want the README file outside, but if it's not in the location, you can do like a mkdir, like a make a directory as a command inside the Docker file just to create it to speed up, but because I already had a README file here, it didn't have any issues. Then we have the dependencies. So first it always starts with like your Python version. So I defined it. You can define it, and I can show you as well when you create your poetry setup. And then it has your dependencies related to your project. So these are quite easy. And then it has the versions. One of the things that I will say is one of the nicest things about poetry is that you don't have to think about how to add or remove dependencies or forgets. So obviously you want to only keep the dependencies that are related to your project, but I can quickly kind of show you something quite cool. Where is it? Okay. So currently I am in an environment, and I'll show that as well, but it automatically creates one for you by just doing a simple command. But when you want to add something, I have to go into this. So let's add PyTest. Oh, poetry add, very simple, PyTest. It will install it, and then as you can see, it will give you the PyTest. If it wasn't compatible, there was, I'm going to see if this one will, oh shoot, poetry add. So for this, as you can see, it's saying, because of versions of Nice Guy match whatever is greater than 1.412 or comma 2.0.0. And Nice Guy depends on Ubicorn on this certain versions. And so then it will say you should define the poetry file that you should do. And you can do version. So we can do, I'm just going to take from the example, I'm not going to do from this Nice Guy, but poetry add, and you can specify which version you want by simply doing the name of it, and then you're allowing a specified version. So, well, this is a range actually. So if you wanted to do let's just add this. Hopefully it doesn't break. Perfect. As you can see, we defined actually, instead of it just doing a caret 4.3.4, it's saying we will take this range between the 2.5.05 2.0.5 or anything that's greater than that. So it's saying a minimum of wanting 2.0.5. It can equal that or more. So there's ways where you can specify specifically, but then also if you're just like, I just want the latest, it will pull the latest. Again, poetry takes from PyPy, so similar to pip. For removing items, so poetry remove, very simple, and then we'll do PyTest. Oops. And then it is automatically removed. So it's very simple, very easy to build and add things. So I also wanted to show you, just on a new terminal, how to build your own so you can do poetry, new, LLM ops, LLM ops, live demo, just for the sake. And so when you do this, it's created it for you. So it kind of does more of an automatic. So let's go into that and then ls. So it's already pulled in. So it gives you a README file, a live demo, your TOML file, and a test folder. So this is a directory as well. So if you wanted to go into that, cd, then ls, we have just an init, but you can start building off of, it's similar to how you would put source. There are ways to make, define your folder structure as well, but for the time being, it's something that you could look at in the documentation. But you could also, oops, let's go to the home. You could do poetry init, and this actually initializes, so let's make a directory, live demo. Let's just put live demo, cd into live demo, oh, demo. Then we can do poetry init, and then it's saying, it actually lets you do the step-by-step. So package name, I'm fine with live demo. Version of poetry, I'm fine with that, but you, again, this is where you can define everything yourself. Description, this is a test. So, but you can describe your project in general. Then you can say no to that's. And then you can change the Python version as well. And then you can start adding dependencies. So PyTest. And then you can choose which one you want. So let's do 0. Let's do pandas. Oh, sorry. Anyways, so add a package. So pandas. This part is just related to what kind of version you want. I don't care at the time. And then 0 and leave blank. And then we'll skip. Would you like to define your development? So again, you can actually define different forms and you can set different dependencies. So I can show that as well. But let's just say no for the time being. And then Yes. So now we can look at ls, and because we didn't define a folder structure, it just puts in the toml file. But if you go into the toml file, you can see that we have the tool dependencies. We have, oops, I messed that up. That's my bad. Then we have pandas, we have Python, and then we can, yep. So, sorry, it's right here to be honest. Here, because it's just doing a confirmation. And so, yeah, this very simple toml file. Again, the lock file is more related to, it will look to see what's in the lock file, or look to see when you run things, so poetry run, or even when you're in the shell. Also, so sorry, with the lock file, then you can, if there's no lock file, it will actually, but you have your toml file, it will initialize a lock file, and you can actually use version control and make sure reproducibility, etc. And so, to go over quickly, is around the shell environment. So when I go into, let's just do an example for the demo from earlier. So when right now I'm not in any virtual environment. So it's very simple and very easy to do. You just need to do poetry shell, and it already has one. So but if it was a new project, it would create it and then it automatically activates. So it's just one simple command by creating your environment and also activating it. And so I can easily do, in this case, I'm just going to pull up a unicorn. This is just inside that server, so I'm just going to run this. Oh, it's already in use. Let me just do, and it will load it because everything is inside the poetry file, the toml file. So then it just quickly is able to run it with no issue. That is the last bit I wanted to show around poetry. Obviously, there's a ton about the publishing and building. So if you weren't using Docker and you wanted to actually, and everything was in poetry, you could even use that as kind of a container and send the wheel file to someone else, and they don't even need to have poetry, and they can run that application. Very simple. So it's very, overall, poetry is something that I've completely replaced pip and even conda just due to the efficiency and simplicity. And so I can actually do all of the fun bits inside and not having to worry about my environment or virtual environments or dependencies. So I definitely recommend anyone if they're interested in switching over to poetry. But thank you all for listening, and if you have any questions, do leave it in the chat. And